Okay, today we're going to discuss types of statistical tests and how to solve them in PSPP. So in this presentation, we're going to use t-test for dependent samples. In this presentation, all the problems in this book are, or at least the data are taken from Modern Business Statistics with Microsoft Office Excel. We're going to use PSPP to compute for the t-test for dependent samples, and we're going to use Excel for the data encoding. As a review, these are the steps in hypothesis testing which you're going to use in making conclusions for your problems. So again, step 1, state the null hypothesis and an alternative hypothesis. Step 2, choose the level of significance. Step 3, select the appropriate test statistic and establish the critical region. Step 4, collect the data and compute the value of the test statistic from the sample data. And step 5, make the decision. So t-test for dependent samples. So a paired samples t-test, also known as your matched or dependent samples, matched pair samples or subjects, simple repeated measures or within groups or related groups, assesses whether the mean difference between paired or matched observations is significantly different from 0. That is, the dependent sample t-test procedures evaluates whether there is significant difference between the means of the two variables, test occasions, or events. The participants are either the same individuals tested on 2 occasions or under 2 conditions on 1 measure, or there are 2 groups of participants that are matched on 1 or more characteristics, example, age, gender, IQ, etc., and tested on 1 measure. So usually this is the test that you're going to use if you're just going to compare pre-test and post-test, because the subject is the same individual, or there is a pre-test, there is an intervention, and then there is a post-test. Okay? Or if you're going to test between groups, make sure that the groups are the same. For example, all students belong actually to say section 1, then all the students have the same, scores, or at least the scores are close to each other in a different test that measures whether the IQ level of the students are the same, or their knowledge of a certain thing is the same. And then you just group them into 2 groups, and then you give them the test, and you can compare now the results between the 2 samples. Okay, so for example, you also want to measure the effectiveness in reducing weight among overweight persons. So that's your dependent variable. Before and after, they underwent a new form of dieting method that uses different kinds of fruits, vegetables, and herbs to reduce weight. So you would like to know if the new form of diet improve the weight loss of the overweight persons. So you can do this by either doing a pre-weight and a post-weight, so meaning you're using the same person as your subject. Or you can also use dependent t-test because we have 2 related groups. So the first related group consists of the participants at the beginning prior to undergoing the new form of diet, and the second related group consists of the same participants but now at the end of undergoing the new form of diet. Okay, so that's one. Or you can also have this one as people who have the same weights, and you just compare if there is a difference between the results. Okay, so you group them accordingly, or group 1 and group 2. Then after 1 week, you compare the results of both persons and you do a paired sample test. Okay. So you match person per person to another person. Okay, but for dependent samples, the best case scenario is actually, or the best scenario to use this one is if it's a pre-test or post-test. For the assumptions for t-test for dependent samples, the dependent variable should be measured at the interval or ratio level, so it's still continuous. So example again are customer satisfaction, intelligence through your IQ scores, and weight or height. Then the sample size must be adequate, at least 30 cases per group. Since you're trying to normalize your data set, so diba? Even if it's t-test, if it's greater than n, you use the z-table, which is your normal distribution. Number 2, the independent variables consist of two categorical related groups or matched pairs. Okay, so related groups, meaning same IQ levels, or matched pairs, that's why it's the same person and there is a pre-test and a post-test. Okay, so related groups indicate that the same subjects are present in both groups. Then, example, before and after scores of the same students. Assumption 3, there should be no significant outliers. So we discuss outliers in your normal distribution. So at first glance, you can actually detect if one of the values in the dataset is way beyond the norm, or it does not conform to the norm or what is usually present in your dataset. So you can just, so if there are significant outliers, then you should remove those from your dataset. And number 4, the distribution of the differences in the dependent variable between the two related groups should be approximately normally distributed. Okay, so that's why you should have at least 30 samples in each situation. So if you're doing a matched pairs, you should have at least 30 respondents. So 30 respondents to answer your pre-test and your post-test. Or if you're going to related groups, so 30 persons in your, at least 30 persons in your first group and at least 30 persons in your second group. For it to be approximately normally distributed, since if it's n is, or the population standard deviation is unknown, but the sample is greater than 30, then is greater than or equal to 30, then you're still using the Z table or the normal distribution table. So how to do your t-test for dependent samples in PSPP? So first, you encode your data for group 1 and group 2 or in PSPP, or at least this is your pre-test and your post-test. Then click on Analyze, Compare Means, Paired Samples t-test. And in paired variables, enter your group 1 as variable 1 and group 2 as variable 2. So example problem, listed here are the pre-test and post-test scores of teenagers in the subdivision for waste segregation and management intervention. At 0.05 level of significance, can it be concluded that reading pamphlets on waste management helped improve awareness of teenagers? So let's have this test. So you should review. So at least there is one data here that might be, might be an outlier. So you can actually omit this one. Actually omit that one. Let's look at other cases. But then 7 and 8, so medyo close na sila. So let's just ignore that one. Might be. Okay. And in your PSPP, so variable view, then we have respondent, pre-test, post-test. So this is scale, this is also scale. I don't have actually. So 0, 0, 0. So we don't have actually labels. This one is nominal. And in your data view, you can simply copy this one. So instead of 60, you now have 59. But see, well, at least 30. So 59 respondents. Okay. So analyze, compare means, paired samples t-test. Then variable 1, your pre-test. napunta, no? So, pre-test, then variable to post-test. This is now okay. Then options, that's 95%. Okay. This is now our t-test. Paired sample statistics, your n is 59. Paired correlation, 0.004. Paired sample difference, sig2 is 0.000. So meaning there is significant difference between the pre-test score and post-test scores, since your sig2 is less than 0.05. So there is significant difference. Okay. Again, you do your six steps of, or five steps of hypothesis testing. So for this one, there is no significant difference between pre-test and post-test score versus your null hypothesis, where there is significant difference between pre-test, post-test scores. And then we have at 0.05 level of significance. So that's your level of significance. And 3 is appropriate test statistic is paired t-test for dependent samples. Okay, then you computed your data and you make the decision. So our computation showed it's 0.000, which is less than 0.05. So there is significant difference. So you reject the null hypothesis.